Okay, we're talking about the periodic table. In 1869, Dmitri Mendeleev noticed that certain groups of elements had similar properties. And so, they've got all these elements, and they were trying to make some sense out of them, put them into some order. So he found that if he lined them up by increasing mass, that there were similar properties that came every so often in a repeating pattern. So when we talk about a periodic pattern, that means a repeating pattern. Just like, our class is periodic. It's every week on Tuesday and every week on Thursday. So he summarized these observations in the periodic law. When the elements are arranged in order of increasing mass, certain sets of properties recur periodically. This is also like notes on a piano keyboard. So this is what reminds me of the piano keyboard. And you might have middle C, and then about an octave above, you've got another note, C. It's just a harmonic of the first one. And then you go up another octave, and there's another C note. It's just higher. Not the same, but very similar. And so here the orange-colored elements have similar properties in the green, and you notice there's this recurring pattern. So what he did is he took the elements that were known at that time and he arranged them in a table so that the elements with those common properties were in columns. So he took that line we just looked at and he stacked up the blue ones and the purple ones and the orange and the green. Now you might wonder, why is hydrogen over here? We'll see throughout the semester that hydrogen is like the baby brother in a big family, like my little guy Andrew, who just turned 8. They somehow managed to get away with breaking a lot of rules. Have you noticed that about youngest children? Maybe some of you are the youngest children and have gleefully taken advantage of that. Hydrogen's the baby brother of the element family, and so he violates a lot of rules. So in some ways, he should be over here, but in other ways, he belongs over there. And on some periodic tables, you'll actually see him in both places. So these columns in the periodic table have elements that have similar properties. There were some gaps in his table because not all of the elements had been discovered yet. And he predicted the existence of those elements, and he also predicted their properties with surprising accuracy. There was a gap. Let's see. Let's look at this table. So this version of the periodic table gives us clues about when these elements were discovered. So before 1800 to 1849. So all the more blue ones were discovered earlier. So silicon was known before germanium. Mendeleev predicted there would be an element found below silicon. He called it eka-silicon. Eka is a prefix that means below. And he predicted the properties, and sure enough, somebody discovered an element there. It was this guy, Winkler, and he named it germanium after his home country of Germany. It used to be that people who discovered elements could name them. And then, things were getting a little out of hand, so we tried to make that a little more uniform. But some of the elements are named after countries or after individuals. There's not really anything you need to specifically know about that periodic table. I just think it's kind of interesting to see when the different elements were discovered. And this is how in 1869 Dmitri Mendeleev completed his first periodic table.
By playing Tetris?
By playing Tetris. Not really, but it makes me laugh. Because this is just like Tetris. Here we've got this block sliding in here, and this one we're going to have to rotate, and it'll go flop down in there. Just a little bit of nerd humor. In the modern periodic table, instead of arranging them by order of increasing mass, we order them by increasing atomic number. If you look closely at the periodic table, you'll find that there are a couple of pairs of elements where they're not in order of increasing mass. Anybody find any?
Cobalt.
Yeah, cobalt and nickel. So nickel has an atomic mass of 58.69, and it's listed above cobalt, which is 58.93. They're really close. But going by mass, cobalt should be before. After nickel. But the ordering property is not the atomic mass, it's the number of protons in the nucleus. When we look at the periodic table, there's a great deal of information. And so I'm going to point out the things that you should be able to identify in the periodic table. There's a dark stair-step line here, starting between boron and aluminum and just going down like stairs. That is the dividing line between the nonmetals and the metals. So in the upper right, we have the nonmetals, and in the lower left, we have metals. The elements that are adjacent to the line, with the exception of aluminum and polonium, we're not going to run into polonium. You should remember about aluminum. All of the elements that touch that line except aluminum are semi-metals or metalloids. They have intermediate properties. We should remember that aluminum is a metal. Anybody have an aluminum cookie sheet at home? Yeah, aluminum is a metal. We know that from everyday life experience. The rest of these guys are semi-metals. You might wonder why these two rows are stuck down here. They actually should be inserted here. Take a pair of scissors and cut the periodic table and spread it apart. That makes it really long for a piece of paper or a screen. We don't use these guys much. They're pretty rare, and so we just pulled them out to make the table more manageable. But you see the numbers 56, 57, and it jumps to 72. That's not right, because after 57 comes 58. And you continue here through 71, and then you jump back up here. So these are called the lanthanides, this row, because they come after lanthanum. And these are called the actinides because they come after actinium. So you should know general characteristics of these three categories of elements. Metals are good conductors. They'll conduct heat and electricity. These are general characteristics. Okay, just like, we generalize about people and animals and things. Not always true, there are exceptions. Metals are malleable, meaning you can pound them into a sheet. You hit them with a hammer, they're not going to shatter into little bits. They're going to dent, and you could keep hammering it and spread it out. Ductile means it can be drawn into a wire. Metals are often shiny. And most importantly for understanding chemistry, they tend to lose electrons when they undergo chemical changes. Nonmetals are sort of the opposite of metals. They tend to be poor conductors of heat and electricity, not ductile, not malleable, and they gain electrons in chemical changes. The metalloids are intermediate. They have mixed properties. They're kind of between, and they are literally between on the periodic table. Some of them are classified as semiconductors because they have some electrical conductivity, but it's not as much as a metal. And that electrical conductivity is highly temperature dependent, and we can modify it, and so that's what makes them so incredibly useful in computer chips. So general characteristics. Other stuff in the periodic table, we have the main group and the transition elements. So the main group in this illustration are the yellow groups. So these two columns over here and the 6 over there. I can't count today. It's the columns that stick up. Those are the main group elements. Main group elements tend to have more predictable properties. Between these two sections of the main group are the transition elements. They transition between. So these are the transition elements, and they are less predictable in their properties. We also have groups and periods. Groups are the vertical columns, and they are numbered. There are 2 numbering systems. And this periodic table on the screen has both. The one on the wall has both, although it uses Roman numerals for the top ones, the 1A, 2A. I prefer the 1A, 2A, 3B numbering system. Okay, I think it just gives us more information. So that's the one I'll use. And then there are periods. Periods are the rows. So here's row 1. Period 1 just has hydrogen and helium in it. Period 2, lithium, beryllium, and then we jump over here. This is also period 2. On some periodic tables, the periods are not actually physically numbered, but that's easy enough to do. Just 1, 2, 3, 4, 5, 6, 7. Questions? 4 of the groups have names that you need to know. The noble gases. If I ask you for a noble gas in period 2, you should be able to find that on the periodic table. That would be neon. The noble gases are the elements in group 8A. They are very unreactive. Some of them do not form any compounds that we know of. The alkali metals are on the other side of the periodic table, group 1A. These are very reactive metals. Technically, hydrogen is not an alkali metal because is hydrogen a metal? No, metals are not gases at room temperature. So there again, hydrogen's breaking some rules. Next to the alkali metals, and similar in their name, so don't get them confused, the alkaline earth metals, group 2A. These are fairly reactive, but not as reactive as the group 1 metals. And then we have the halogens in group 7A. And these are very reactive nonmetals. We can predict what kinds of ions some of the elements will form by their position in the periodic table. Main group metals tend to lose electrons. Metals lose electrons, they form cations. And they tend to do that, the main group ones do that, so that they have the same number of electrons as the closest noble gas. We'll look at a periodic table in a minute and discuss that again. Nonmetals tend to gain electrons, forming anions. Nonmetals make negative ions. They both start with N. Nonmetals make negative ions. And they tend to gain those electrons so that they get the same number of electrons as the nearest noble gas. We'll be discussing later in more depth, maybe more depth than you care to hear about, why they do that, but for now we're just going to say that's what they do. So those alkali metals in group 1 are going to lose 1 electron. They're going to form 1 plus ions. Group 1A elements form +1 ions. The alkaline earth metals, group 2A, they tend to lose 2 electrons and form a 2 plus ion. So group 2, 2 plus. The halogens in group 7A tend to gain 1 electron. They form 1 minus ions. And the elements in oxygen's family, group 6A, tend to form 2 negative ions by gaining 2 electrons. So this is what you need to remember. Main group elements that form cations with predictable charge. The charge is equal to the group number. For main group elements that form anions with a predictable charge, the charge is equal to the group number minus 8. I'll show you another way to memorize that or remember that, but group number minus 8 works. And then the transition elements form lots of different ions, and they're not predictable from the periodic table. Let's look at the table now. Okay, so these group 1A elements all will form +1 ions. So let's think about lithium. So lithium has how many protons?
3.
It has 3 protons. How many electrons does it have? As an atom, it has 3. If it has 3 protons, it has 3 electrons. So if it loses an electron, how many does it have? 2. Which element on the periodic table as an atom has 2 electrons?
Helium.
Helium. So what lithium does is it loses an electron so that its electrons look like helium's electrons. I think I told you last week that I think of electrons as being like the clothing on the atoms. And so I remember, especially with my oldest son, he wanted to wear similar clothes to what everybody else at school was wearing, right? Hollister hoodies were a big deal. Very expensive. Now they're hanging in the closet. None of the other kids want to wear them. But he had to have a Hollister hoodie. You go to drop him off at school, and everybody's wearing Hollister hoodies. It's the in thing to do, right? So for these main group elements, these guys, by losing 1 electron, then they have the same number of electrons as the noble gas right before them. So it's like they're changing their clothes to look like the noble gas. These elements have to lose 2 electrons. So magnesium. Magnesium's element number 12. It has 12 electrons. If it loses 2 electrons, it only has 10. Which element has 10 electrons as an atom? Neon. So they lose electrons to become like a noble gas. Do they become noble gases? No. If you dress like someone, you do not become them. You just look like them. So these atoms, when they become ions, they're going to look like a noble gas on the outside in terms of their electrons, but the number of protons doesn't change. These nonmetals, it would be very hard for fluorine to lose so many electrons to become like helium. It's much easier for fluorine to just gain one electron and become like neon. So these guys being closer to the noble gases moving to the right, they're going to gain electrons. So fluorine gains one electron to become like neon, oxygen gains 2 electrons to become like neon, and nitrogen gains 3 electrons to become like neon. So
Does carbon do anything?
that's a good question. What about carbon? Well, carbon is right here. He'd have to gain 4 electrons or lose 4 electrons. And so I think of these guys in group 4 as being a little bit like those happy nerds. You know, it's like, I know I'm not like the cool kids, but I don't care. I am just going to be me and go through my life, and I'm not going to try to change. It's too hard for carbon to go either way. Carbon can form ions, but it rarely does, and we're not going to run into any of them in this class.
Phosphorus isn't doing anything?
Phosphorus does, and I do not know why they left phosphorus off this table, so I'm going to put him in.
Does it do the same thing as?
It does the same thing as nitrogen. Wait, I didn't want purple, I wanted black. So phosphorus is right here. So another way to remember what these charges are is think about counting backwards. Maybe you're playing a weird board game, and the starting place is on the noble gas, and then you count backwards. -1, -2, -3. -1, -2, -3. So phosphorus will form a -3 ion. And below phosphorus is astatine, which is a semi-metal, and so he's not really going to do much of anything. Semi-metals are kind of unpredictable. Tellurium will form an ion along here, but phosphorus is the only one on here that we need to worry about. Aluminum. Aluminum's kind of like in the middle of the periodic table here, but it's in group 3A. And it forms a 3+ ion by losing 3 electrons. Any questions? These ions on this table, you should be able to predict their charges, and we do that just based on position in the periodic table. Now see, here's hydrogen in 2 places. Hydrogen forms a +1 ion by losing its only electron, and it also forms a negative ion by gaining 1 electron. Okay, so predict the charges. Predict the charges of the monatomic ions. So nitrogen. So we have to identify a number. We also have to identify, is it going to make a positive ion or a negative ion? And you identify that by asking yourself, is it a metal or a nonmetal? Is nitrogen a metal or a nonmetal? It's a nonmetal. We can tell that because it's on the nonmetal side of this line. If you don't remember which side, pick an element that you know something about. Helium. That's what they put in balloons, right? Would you fill a balloon with a metal? No, that'd be dumb. Helium is a nonmetal. All of these guys are nonmetals. We know what iron is. Iron is a metal. All these guys on this side of the line are metals. So nitrogen, being a nonmetal, is making a negative ion. And to figure out the charge, we just start here, 0, -1, -2, -3. Nitrogen has a -3 charge as an ion. And so when we write the charge, it's a superscript. We write the number first and then the sign. How about rubidium? What kind of a charge will rubidium have as an ion? 1+. So we find rubidium on the periodic table. It's in group 1A. All of the group 1A elements form +1 ions. And so when we write the symbol for that ion, it's the element symbol with the charge. Plus. Why didn't I write a 1? Because chemists have a thing about writing the number 1. You'll find throughout the semester, we just leave 1s out. We do write the sign here, because if we didn't write the sign, then how would we know that it has a charge? And the sign always comes after the number. It's the opposite of exponents in math. If this was the variable n to the negative third power, you'd put the minus in front of the 3. So we're doing it the other way around so that it doesn't look like an exponent. Any questions?